So this solution is correct. However, it might feel a little bit repetitive. So we are explicitly listing all the 6 cases. So can we make the code a little bit more succinct? And in fact, we can. Even if we are enumerating through all the answer, we can make the code a little bit more succinct by using lists. So this is the first kind of data structure that we introduce, in the sense that it can store multiple value together and then you can use them. So a list value is represented by a pair of square brackets with the items separated using comma. And the list items are indexed. So the first item has the index 0, next has 1, 2, and so on. So this list have 6 items, and their indices are 0, 1, 2, 3, 4, 5. And to access an item of a list, we use the name of the list or the variable that contain the list value, and the square bracket, and then this I gives the index of the list item we want to access. And list items are changeable, so we can assign value to messages. So here we have a few lines of code. So let's run it on online GDB. So if I run this, what this is going to produce. So form your opinion, and let's see. So the first thing that produced is the 5, 6. So that is this item. So this has index 1. The second line is 1, 6. So that has the last item that have index 5. So I can change the value. So for example, if I write messages 1 equals some random thing. So let's make it 3 4. And then if I print this again, I'm going to see 5, 6, 3 4. So this value has been changed. We can also print the messages, print the whole list at this point. And you can see this is printed out using this list value format with square brackets. And the value with index 1, the second value has been changed. So you can think of a list as a file cabinet. It has many boxes, and they are labeled with numbers. And the numbers are sequential, and they start with 0. And you can put things into boxes. You can take things out, and you do that by referring to their numbers. And to get the length of the list, which means that the number of elements in the list, we can use the built-in function len. So this format. So you throw in a list value here. This will give you the number of items in that list. And if you have some experiences with other programming languages, you may know about arrays. So lists are very similar from arrays, but there are slight differences in the sense that in the list, you can put in values of different types, but typically in array, in other languages such as C and Java, we will expect those values are of the same type. For now, we are just using Python list. So using list, can we make the code more succinct from than the one listing all the case? And the answer is yes. So we define the messages in this way in a list, and then we can simply just print out the correct message. And the correct message index can be computed from the max of y and w. And it's basically the max of y and w subtract 1. Because the max of this will go from 1 to 6, and the indices go to 0 to 5. So we need to subtract 1. Now, if for some reason we want to insist, we want to just print the messages using the max at the index. So we can still do that. What's needed is we need to modify the messages a little bit. So we can define the message by having a first element that we are actually not going to use. So now this list has 7 element indices from 0 to 6. So we are actually only going to use the value from 1 to 6. So that's why for the first value I put in not applicable. So I can put in anything here because we're never going to actually use that in this program. So now the question is we are not really solving the problem mathematically. We're almost like cheating. So we figure out there are only 6 possibilities, there are only 6 possible output. So we just hard code them and then print it out. So what if we want to solve the problem more generally? So to make this meaningful, so we are going to generalize the problem. So instead of a 6-sided dice, we have n-sided dice. So n can be any integer. So if you think there cannot be, say, 475-sided dice, then let's just say there's some random mechanism that can generate a random integer between 1 and n. So we are given the maximum number possible value for dice throw, and we are given 2 dice throw value, y and w, and we want to compute the probability that what's the probability that we throw a new value that is guaranteed not to lose. So it will be at least as large as the larger of y and w. So this is to generalize this problem from n to 6 to arbitrary n.